going forward. Like we've been mentioning, as we build out of this stuff, each consecutive day, basically, in this chapter, has basically added one step to all of the work that we've done. Remember when we first started these problems, the first part of the chapter was solving for x in a ratio. The second, or in a proportion. The second part of this was to work with the ratios that are built within triangles, which meant that they gave you the lettering and you had to fill in the blanks. Today, it's going to be a matter of, excuse me, a matter of knowing that you have a similar figure, which means you have to come up with the similarity statement to fill in the blanks to solve for x. So all we're doing is just basically adding one step on top of what you've done over the past few days. Okay? And if you have any luck from yesterday, seeing how relatively straightforward it was, this is going to be a piece of cake. Okay? Because once we know that we have what are called similar figures, all of the corresponding parts are going to, for the angles, will all be congruent. And then for the side lengths, they're all going to have the same ratios. Okay? So, our recommendation for a problem that looks like this, as soon as you are given what's called a similarity statement, you all right?
Yeah.
As soon as you're given what's called a similarity statement, write out the fractions that are created, just like we did to check to see if something was similar. So go through the lettering. I'm just following my letters here. A, B, C, which means I have A, B, B, C, and A, C. Those are the three side lengths. I'm just going in order off the letters. I'm not even looking at my diagram yet. The reason why I'm not looking at my diagram is because this statement here, single squiggly, tells me right away that I know for certain that it has to be excuse me, similar. Yes, ma'am.
So with the last piece AC, does it matter if it's AC or CA?
Yes.
Okay.
It's the same thing. I think it's always habit for me. You're right. I probably should say CA because I'm coming back around the triangle.
That's just easier for me.
That's fine. I'll write it that way. It's just habit for me to always just to say AC. I don't know. Excuse me. So now I create my fractions. I'm checking. I'm going to write these out. I do the same thing. So it's PQ, QR, and RP.
G.
Okay? Now, I've written my similarity statement. Now this looks exactly like a problem we did on Wednesday. Fill in the blanks. What do you know? I know that AB is 14. I know that PQ is X. I know that BC is 6. I know that QR is 9. I know that CA is 15. And PR is 22.5. Does it matter which of those fractions I use to solve for X? Nope. Not at all. Not at all. Cross multiply and solve.
Probably easier to use your calculator.
Yeah, but you have a calculator.
Yeah.
Or could I even make it easier on myself? Could I simplify the 6/9?
Oh,
I can find a scale factor right away if I wanted to. Yes, sir.
Okay, so what I figured out was as triangle ABC is 2/3 of PQR.
Right, that's the scale factor. That's the idea. So you can get the scale factor right away and use 2/3 to cross multiply, or just use your calculator and do 6 times x is 9 times 14. Divide it by 6. 3 and a 2, divided by 7, you get x is 21. That's it. We've added one step to your problems, guys. I know your problems are compounding.
But then,
So we're adding to them. It was a lot funnier if you would have understood that joke, so. Oh well.
oh,
hear about the new tank?
No.
And it goes 1 mile per hour or forward and 19 miles an hour in reverse. It's a World War
Same
II.
idea. Take a second. No, we're just going to add to it today. 'Cause we're just going to take it a step further. Take a second and do these two, please. What's that? You could have, gotten binoculars. It's not too late to ask for them for Christmas.
That's exactly what it is.
Again, our suggestion to these things always and always and always will be, write out the similarity statement in terms of fractions before you do anything else. Because if you ask me, I don't know what to do, I'm going to say to you, did you write out your ratios? It is an A. If you want to, yeah. I just give you guys a few minutes to start on homework and stuff, because I really only have, I think, 2 or 3 examples left, and then I'm just going to cut you guys loose. So when I'm talking about scale factors, remember, your best bet is always to start by writing out your fractions. RS, ST, TR, XY, YZ, ZX. And from there, fill in the blanks. Just fill in the blanks. 45 is to 50, as 27 is to 30, as A is to 40.
That's all you have to do.
That's how I start. Now to get the scale factor, all I do is just simplify one of them. 9/10, I believe. So the scale factor is 9 to 10. Now the question here asked us to go from the triangle from RST to XYZ. It went from left to right. What happens if I asked you guys what's the scale factor from XYZ to RST? What would your fraction be? Flip. Yeah, you just flip it. A lot of times they will, the way that I would generally set these things up is I would always set it up as I read it, left to right. Don't be surprised that if you read a question that it asks you to go the other direction for the scale factor. They do that to you to make sure that you understand how to read. So now that I know the scale factor, to find the value of A, can I use the scale factor or do I have to use one of these other 2 fractions? Use the scale factor because it's easier. So you know you have a 9 and a 40. Hey, what's A? Oh, I'm sorry, a 10.
40 times 360 divided by 10, that'd be 36.
There you are. Or if you look at it numerically, 10 times what is 40? 4. 9 times what? 9 times 4 is? 36. That's it. But, or you cross multiply like you did Kib, and that's fine as well, man. There's nothing wrong with that. Nothing wrong. Cross multiply and solve. Yep. You're going to see a lot of this whole cross multiply and solve stuff when we get into trig. Something like that. Yeah, or we'll be doing a lot of this stuff there. The other thing here in
Yo, you want to try to pull my hair again?
Calm down. If that wasn't me, what if that was Jason?
Same thing would have happened to you.
Huh?
I would have done the same thing with him.
He feels messy.
and this is that last little bit of this really.
What'd you do?
In similar polygons, yeah, polygons is just too many letters to write. In similar polygons or similar figures, no matter what it is, whether it's a polygon, a triangle, whatever, in any similar figure, the perimeters between the 2 similar figures will have the exact same scale factor as the sides would have. Okay? You're going to have the same scale factor whether or not you have the sides or if you have the perimeters. Okay? It's always going to work out nicely for you. Which means then you can solve for perimeters without too much of a hassle. If I go back to the example we just did, we had two triangles. We had a triangle that, what was one of them? Was what, 27?
Over 30.
It was 27 something and something. The other one was,
47, 45.
Some had 45 on it. It was one or two.
I guess I can just do this.
True.
So it was 45, 27, this one was 36. This was 40, 30, and 50. So if you look at the two triangles we just worked with, what's the perimeter of the triangle on the left? Well, what's 45 plus 27 plus 36? Press the buttons.
Somebody's gonna say.
How much?
108.
108.
Ives. Ives.
What?
Morning, sunshine. So it's 108?
Yo, won't try to call me sunshine again?
Or you add them and then you divide it.
The other
Yeah.
one's 120.
Sunshine.
How would you divide by 2?
And this
Because that's
whiskey,
twice as big
have a
as that.
seat. Whiskey, have a seat. Relax, man. I just would like you to keep your head up, okay? When you simplify that fraction, what do you get? 9 cents. Same thing, isn't it? That's what happens, guys. What's that?
What about the fourth?
It's a triangle. It's just really badly drawn.
It was actually the same triangle.
If you, thanks, Hannah. What? No, thanks. All right,
He
whatever.
didn't feel bad enough, Hannah, now he feels even worse.
Start crying.
Really just gave him that.
Mr. Murphy, it's
we're done.
okay, no one's
We're
judging
done.
you.
Let's go. Let's go.
I'll teach
Now he's gonna sit and rock and shout.
So, same idea here, guys. Same idea here. Now you'll start to notice that we're going to get diagrams with less information. You're going to get diagrams now with less information, but you're going to be given still a similarity statement. When you're given a similarity statement, all you have to do is the same thing. Write out the fractions. So in this diagram, excuse me, it tells you that the funky figure on the left, A, B, C, D, is similar to the funky figure on the right, F, G, H, and J. So when I start this again, I start always by writing out my fractions. Always, always, always. It's the easiest way to do these, and it's really hard to screw it up if you do that. Okay? Excuse me. So I just go through my lettering. A, B, B, C, C, D, and D, A. What's the other side? G, H, J, and J. What do you think you do next? That's all it is. Fill in the blanks. Fill in the blanks, exactly. So we go through our list. We have 15. F, G, I don't know. So if you look at the other figure, can I label the missing side links as X, Y, and Z because there's 3 of them? Is that okay? Sure. Thanks.
No.
Just to keep them like that for right now. So I have an X, BC is 8, GH is the Y, CD is 10, and a Z, and a 12, and an 8.
Whoa, so you have to use that last one all the time too.
That's all it is.
You can reduce it too.
Reduce it and then
Yep.
use it.
Yep. So, out of these 4 fractions, there is only one of them that has number over number. It's the last one.
Do you ever have one that doesn't have that?
That means you've probably done goofed.
Okay, so you won't.
So here I have a ratio of 12 over 8, which means what is that as a fraction?
It's 3 seconds.
3 over 2. So the scale factor going from left to right is 3 over 2, but it wanted you to write the scale factor going from right to left. So what would your answer be? 2/3. Very good. Now I still have this down. Since I wrote my statement like this, I'm just going to use what I did. Okay. It's now going to ask me to figure out what the perimeter of FGHJ is. Now there's two ways of going about doing this. I could find X, Y, and Z, or remember, perimeters have the same ratios. Wouldn't it be quicker just to figure out the perimeter of this and use one fraction? So the perimeter of 15, 10, 12, and 8, well, that's 20, 30, 45.
So that'd be 30 for the other one.
45 here, and something there. I know I used X earlier, so I'll just use P for perimeter. And you're right, when you cross multiply stuff out, you get 90 equals 3 times something. What's that?
Yeah, why wouldn't it be 2/3? You changed it.
The reason they asked the question to start with, the going from right to left. When we wrote out our original statement, we wrote it from left to right. Since I rewrote all of this already, I'm just going to keep it that way.
So if I did it opposite, I would put
45 on the bottom.
You just put 45 on the bottom.
Do you see that if you switched it, just switch the other?
Yep, because that way it stays consistent. Okay, and that's where this becomes a little bit more complex. Is that you just have to realize what direction are you going from, and once you nail that down, it's really easy. Okay. So P, your perimeter of the smaller figure is 30. Now it could ask you to solve for all the missing parts. In this case, it didn't. We just got to find the perimeter. Okay. Not terrible. I think I only have one more. I'll let you do this one, and we'll check in a couple minutes.
I'd rather die.
So, let's
What's
see.
it done? Was it?
No.
Exactly.
I just hope that it's something that happens in
See,
like I said, I need to really die.
RS. So let's see here. LM 14, 12, 16, 12, 8. CU is 20 is the only one we know.
Yeah.
Oh, and we have a diagonal.
That'd be 4/5, right?
So my diagonal, I'll say, is MO. Has to be SU.
It can be reduced, right? To,
Yeah. Yep.
4/5.
So what we've got here, guys, is I'm just moving things around where I wrote in that diagonal because we have to have the consistency portion of it. Sorry. Just real quick. Yes, I'm messing with my watch now that I'm trying to.
Anything mechanical, give it to the back.
So what we have then is that missing portions here. We have to find the length of that diagonal, MO. We know that this one was 25. So we use that middle fraction, 16 over 20. You simplify it, you get 4/5. That's going from left to right for the scale factor. The question asks us for scale factor going from right to left, so we'd have to write it as 5/4. I'm going to still use this value here to solve the rest of the problem because I already have it written out. So I would just move this up and say 4/5 is that other diagonal over 25. What's the diagonal? 20, very good. So the missing diagonal is 20. It also asked us to find the perimeter. Well, I have to find the perimeter using the scale factor of 4/5. I'm going from left to right, so I have to figure out 14, 12, 16, 12, and 8. Well, here's 20, 36, 50, 62.
Nice.
And what was the answer then? Cross multiply out. 15, 5 times, was it 4, 1, 65? 82?
I got 77.5.
I got 77.5.
I
Or
think
one and a time will be
wrong. We got 77.5.
Oh yeah, I thought it was divided by 5. That's my fault. So what'd you get for an answer? There's your perimeter. Yeah, 155 over 2.
Yeah.
And I think we discussed this yesterday. And sometimes decimals aren't the end of the world. I prefer not to use them, but you know, if it's a halvesy, a quarter, something along those lines, by all means, just use it. Okay? That's about as complex as this stuff gets, guys. Just you have to remember the things that with correspondence. Okay? So homework stuff is on the same page as what you were working on. I forgot what that was.
670.
What was it?
376.
376? Yeah, I think we have more on there than it's numbers. Just add to what we have. Was it 9 through 12? And then 19 through 25.
Add on, you said?
Yeah, just add those to what you did from yesterday, okay?
That's not one.
And it's a lot of, look at the picture. I can't stress the fact of writing out that fraction part because it allows you to do everything, okay? It might take an extra minute or so to do that, but as you get through these things, it really forces you to fill in the blanks and solve it, okay? You guys got about a good 10 minutes or so. You should knock out a couple of these without a hassle, all right? Sinus pressure is fun. No, okay, not really. Not at all. I'm faking it well, though. Yeah, if Hannah was such a meanie beanie.
Make it cry.
Hannah, go to the corner.
I am actually mad at you. Yes, I am.
Did you hear about Dexter mom?
Yeah, you know,
I'm
Oh, why is he going to St. Louis?
it's, you know, money talks, man.
Who's him, not to me.
I've read a lot of interesting stuff about that.
I mean, he
So
wasn't going to come back last year,
No.
so I get that. So he wasn't planning on staying. I can
I'm mad at
respect that.
yeah.
People